Next, we're going to move on to our autonomous vehicle and AI in transportation panel, Driving Innovation with AI. So for this panel, we have a number of illustrious innovators. We have Zoubin Ghahramani, who's the chief scientist at Uber. We have Vincent, who's the EVP of autonomous driving tech at Lyft. Ashu Rege, who's the SVP of software at Zoox. And the panel will be moderated by Matt Park, who's the head of business at Scale AI. Welcome, everybody.
All right. Test. Are you guys able to hear us? Yes? Audio's good? Okay, great. Well, I know that was a brief intro, but maybe it would be good if folks could just take a moment to introduce themselves. And so maybe starting with Zoubin in this way.
Hi, I'm Zoubin Ghahramani. I'm Chief Scientist and VP for AI at Uber. I've been an academic for most of my career, also a professor at the University of Cambridge, and an MIT PhD. So that's relevant for this audience, I guess.
Hi, Ashu Rege. I'm the SVP of software at Zoox, and I've actually taken an opportunity to introduce Zoox because it may not be as familiar to people as these other two companies. Zoox is a company that is developing autonomous mobility as a service, and we are doing it from the ground up, including building our own vehicle from the ground up, designed to solve the autonomous mobility problem.
Hi, my name is Vincent. I lead the Lyft AV team, which we call Lyft Level 5. It's right down the street in Palo Alto. We started this about 2 years ago. Before Lyft, I was at Google for about 12 years, where I led the Street View team, among others. And in Street View, we built some of the tech that really is used for AV as well. So, in fact, we helped incubate Chauffeur, which is now Waymo.
And lastly, I'm Matt Park. As mentioned, I lead the business teams at Scale. We're a venture-backed company that works with leading enterprises to accelerate the development of AI, particularly for computer vision and NLP applications, by tackling the problem of ground truth data generation. So come find us later. Want to thank everyone here for making time and being here. And the topic of this whole session is transportation and driving innovation in AI. And so maybe to start off, I think when people normally think of that topic, the head immediately jumps to self-driving, but it's actually much more broader than that. And so maybe to start off, where is AI currently being used in the transportation industry today? And maybe, Zoubin, if I can start off with you as well.
Great, thanks. Yeah, so when I say I work at AI at Uber, people do think that I work on self-driving, and then I have to say I work on everything except autonomous vehicles. So what does that mean? So first of all, what do we mean by AI? Modern AI is just data-driven algorithms for solving perception problems, prediction problems, and optimized decision problems. And actually, if you look at a business like Uber's, we have AI problems everywhere in the business. So from understanding and modeling the complex dynamics of cities, predicting supply and demand, ETAs, dealing with our customers in a natural way, conversational interfaces, computer vision problems to solve safety issues. The number of AI applications is huge, and it runs through our rides, our eats, our freight, our autonomous vehicles, of course, and jump, scooters. All of these areas require AI and machine learning technology. And the way you kind of think about it is, there is this shell of interactions that we have with millions and millions of people in the world. But at the core of a business like that is algorithmic optimization of the way transportation happens in the world. So that's where I see AI fitting in, sort of at the heart of optimizing the movement of people and things in the world.
Ashu or Luke?
Yeah, obviously we at Zoox work primarily on autonomous mobility and self-driving. And as actually Kyle mentioned, the numbers are pretty staggering in terms of what can be achieved by solving this problem. So maybe it's not quite addressing the problem you talked about, Matt, but I'm talking more about solving the driverless problem. And there, it's 40,000 people a year in the US alone that die. It's 1.25 million in the world. So by the time this panel's over, there'll be 70 people who would have, unfortunately, no longer with us at the end of this panel. And that's it, crazy if you think about compare that with cancer deaths, that's 9.6 million roughly, but that's more of a much harder problem in many ways. And the 1.25 million for that are dying, 95% of those are in crashes. And at Zoox, we have our Chief Safety Innovation Officer is Mark Rosekind, who joined us from NHTSA, and he taught us repeatedly, don't use the word accident, because it's not an accident. It's a crash. And the reason it's not an accident is because 95% of the fatalities are caused by human error. So, which is staggering if you think about how much we are allowing this to happen. And so I think I really believe, that yes, there will be a ton of utilization of AI all over different aspects of transportation, making things far more efficient. But I think this fundamental problem, if we move past it and have this autonomy available, is going to be just tremendous in terms of how transformative it's going to be for society.
I guess thinking about the whole space and how rapidly it's changing as a whole, any specific trends or research that you're pretty bullish or excited about that have come up recently?
Well, I can think of two. So I've been particularly excited about new technologies that are used, for example, in perception, to do a better job of machine learning and not just image data, but say point cloud data and other kind of data, like radar data and things like this. So how we can sort of go faster, innovate faster in this space through things like Stanford research and things like F.net and others. So that's one. I'm also very, very excited about, in fact, some of the things that Carl talked about, imitation learning. So if you think about it, Lyft has already an enormous service, and we have tons of drivers in this service. Can we somehow learn from their behavior at intersections, on highways, on sort of back streets, to build a system that can actually imitate the behavior? If you think about it, if you build a system that will simply sort of follow the lanes very, very tightly, you end up with some sort of robotic behavior that's not very natural. Could we do better? Could we somehow, turn left at some intersection exactly like most drivers and therefore be safer in the process? That's what I'm excited about.
Got it. Zoubin, I know.
Yeah, so I've been sort of for much of my career, I've been in the academic world of AI, and I've seen a lot of trends come and go. And of course, everybody here knows deep learning is the thing. But what I'm going to tell you is deep learning is pretty passé as far as I'm concerned, in the sense that, well, first of all, we've had waves of it for decades now. We're in a good wave now. It's being commoditized. We can use it for all sorts of things. But honestly, all deep learning is you throw massive amounts of data at a function approximator, and it learns a function that maps from some inputs to some outputs. What's so exciting about that, honestly? There is a lot more innovation and excitement that the academic world and the research world can bring into industry. So one of the things that I'm really passionate about, that I've sneakily managed to introduce into many parts of Uber, is probabilistic modeling. It's a sort of building models of complex systems. So don't think of function approximating or neural nets or anything like that. Build models of complex systems that you can learn from massive amounts of data from which you could simulate. Simulation is something super exciting and something I'm also passionate about. And understand potential behaviors of a system and improve that over time. And if you think about machine learning and AI not as just fancy function approximation, but modeling complex things in the world, then suddenly it opens up huge avenues in the sciences. It opens up stuff in industry and engineering, et cetera. And so this is, I think, part of the future. It's part of the present, certainly. And it's one of those research trends that I feel now lucky to be able to actually introduce into a lot of our internal products and things.
Ashu?
Yeah, I agree with some of these observations. One of the things that, like for example, what Kyle mentioned about AI teaching AI, we are starting to see that at scale happening at Zoox, and I'm sure other companies are doing that, which is tremendous because a lot of the AI problem is about understanding what is ground truth. And you kind of have this human in the loop today that helps you do that. That says this is what reality is, and then you have your AI that goes, I see what's going on here, and creates that approximation, so to speak. But then the question is, how do you do that at scale? How do you do that with literally the gigabytes per second of data that Kyle mentioned? And who looks at all of this data, right? And that starts becoming its own problem now. And so that is definitely exciting. The other aspect, which we haven't touched on yet, is I think there's a lot of exciting developments happening in sensor technology. And it's kind of cool because I think what autonomous vehicles, as is potentially incredibly large industry, is now fueling is a lot of startups that are now feeding into that ecosystem going, how can we build really robust, reliable cameras that can see really, really far? And other sensors, for example, LiDARs and infrared and all of these innovation that in areas that are kind of stagnated for a while. So I'm pretty excited about a whole bunch of startups that are coming in that are going to build these new set of sensors.
Very cool. Very cool. Just hearing Kyle kind of give a charge to all the attendees about tackling the problem in AV, and kind of curious more broadly, incredible group that can be tackling some of the hardest problems in this space. What do you think are some of the major technical or non-technical challenges in AI for transportation, self-driving and otherwise, that you think these folks should be aware of?
Maybe I can take a stab at it.
Yeah.
I think maybe I'll start by echoing some of what Ashu said about the labor data. We are a very good customer of Scale, by the way, I should say, at Lyft. Scale does a lot of data labeling for us. But is that sustainable? Can you keep doing this forever? We would love to find a way and to deploy more systems that don't have to rely on this labor data. So that's why imitation learning comes into play. That's why maybe unsupervised learning is something we're very excited about. The other thing that's also exciting is the future of the promise of potentially being able to keep your networks fresh as you evolve. When you deploy self-driving cars in the world, you actually change the way people behave. So and in fact the environment changes anyway, but you contribute to it. So can you somehow keep the network performing at its best automatically? Can you adapt your network to different cities and different environments with some sort of meta learning system? That's, I think, a very exciting area which we have just barely started to explore.
Yeah, and if I can jump in on that, so that aspect of adapting is hugely important in almost all interesting areas where AI is being used, like even things like fraud and safety and things like that currently. And part of the problem is that human behavior is so complex. So a lot of the challenges in sort of AI come from the fact that we're using AI systems in complex, dynamical environments where we have a lot of humans doing lots of things, sometimes fraudulent things or unsafe things, sometimes mischievous things like pranks they could play on a self-driving car, for example. And sometimes erratic things like bad driving or inattention. All of these aspects of getting these complex algorithmically driven systems interacting with slightly difficult to model humans. That's really where a lot of the challenges come. And I think it requires a sort of a level of creativity in terms of the way we make our AI machine learning systems robust and adaptable, which is what Luke was mentioning.
I'm sorry, any other thought?
I can. Ashu.
Well, I think interacting with humans, especially for autonomous vehicles, is going to be the most interesting challenge, no doubt. There are things we do as humans that we don't even think about, but you get into space, and then now every time you're driving, there's always this meta thing running in the back of your head, like, how would the AV do that? And so you start thinking in those terms, and you go, man, this problem is not that easy, is it? Very simple things, like you're at an intersection, there's somebody there, and they're on a phone, just a pedestrian, and they're not going to cross because they're on the phone. How do you teach an AI to see that and say, okay, you can go? As opposed to you do the eye contact thing with the person and say, okay, are you going or not? And then they go, right? And then there's that whole negotiation that happens. Well, now you remove the driver. How does your vehicle do that interaction with that person? And so those are kinds of nuances that we take for granted and that humans are really, really great at. We tend to be really awful at geometric type things, but in terms of precision. but we are really good at these sort of higher level things. And so I think that's going to be the big hurdle that these AI systems are going to have to sort of cross over before they become viable in these types of domains. Yeah.
So what I have to add is that I think the biggest challenge can be boiled down to what we call in this business the long tail, right? So when you rank, the scenarios, the situation you come across, while you're driving, you have the very, very frequent situations on the left, and then you have, a very, very long tail of things that are happening with less and less frequency. And it's very, very long, right? So at the, end of the spectrum, you've got maybe you're just following a car in front of you. That's the most common situation. In the more rare cases, you have maybe some puff of smoke or some dust from some vehicle that's causing your perception to potentially hallucinate that there's some obstacle. And then very long tail might be, say a moose, crossing the street in San Francisco, or an alien spaceship, landing in front of you. Well, so all these situations, you don't have to deal with them all, equally well. But somehow you have to be able to prove some level of safety across. And so that's where I think, if you were to do this simply by observing the world, you would need tens or hundreds of thousands of cars driving around, which is impractical. So you really need simulation to play a role here. Also, I think you need to probably be building a system that can be very efficacious across the board. So be very, very good at dealing with sort of common situations, but doesn't have to be elegant across the board. It has to be elegant, really smooth in dealing with the most common things, but it has to be, good enough for the very rare things. For the very rare things, maybe you just detect it through machine learning and just slam the brakes. That might be enough.
Got it.
Something to think about it.
Yeah. I mean, we're hearing both a number of interesting challenges. You guys mentioned some new technologies you're interested in as well too. So I guess more broadly, if you were almost to give out a charter to future alums or future grads, where should innovation go next? Like, where is there need for more innovation in the broader transportation space? It's a lofty one, Zoubin.
Yeah.
Lofty.
Yeah. So I want to get people, if you'd asked me a few years ago, I was an AI researcher, but I had nothing to do with transportation, right? And if you'd asked me a few years ago, is transportation exciting, interesting? I would have said, nah, what? It's just it wasn't kind of in my sort of AI, motivating thing that got me excited about being in machine learning and things like that years ago. Now things have changed because self-driving is becoming a reality, and people see that, and the sort of grad students and postdocs or young people in the field get super motivated by this. What I want people to think about when they think about AI and transportation is, it's going to sound a bit weird, but I have a background in neuroscience. And one of the questions that most neuroscientists never ask themselves is, why do we have brains? Okay? Not all living organisms have brains. Plants, trees, they don't have brains. The organisms that have brains are the ones that move, okay? So the purpose of the brain is movement. And there is an animal that's a very good example of this, which is the sea squirt. This is an example I got from my colleague, Daniel Wolpert. The sea squirt has 2 stages to its life. In its early stage, it moves like an animal. Then it plants itself, and the first thing it does when it becomes stationary is it digests its own brain for energy, because it doesn't need it anymore. And my friend Daniel said that's also a good model of tenure in academia. So, of course, not all the tenured MIT faculty. Sure, they don't digest their brains. But this is what I want people to think about. And this is not exactly an answer to the question, but I want people to now think about AI and transportation as brains and movement, okay? So whether it's in the self-driving domain or whether it's in the, everything else, ride share, bikes, e-scooters, et cetera, public transit systems, that algorithmic brain of cities that optimizes movement is what I think we should be excited about.
Yeah. One of the challenges I would, people I think ought to look at seriously is, there are two aspects to solving autonomy. One is solving autonomy itself. And then the second is, how do you know you have solved autonomy? How do you prove to yourself, first of all, as a responsible member of society to say, yes, my team has actually figured this out. And it is safe now to take the steering wheel out, to take the driver out, and these things can go out there and they'll be fine. Even handling the long tail problems safely, right? So proving that the second part is almost the same problem as the first one, as it turns out. And there's a lot of innovation and work to be done, I think, in how do you decompose the problem. And by the way, the proof is needed, of course, for yourself to feel good about putting your product out there, but you also need it for regulators. You're going to need, at some point, no matter where, to show the world, and regulators representing really people, all of you, and all of us, saying, okay, you're putting this product out there, how safe is it? Because this product can kill. We know that. And so how do you allow this to be on the streets? And so that aspect, I suspect, doesn't get as much discussion in the press. Everybody talks about the dilemma problem of do you go here or there, et cetera, which is nice, but it's such a corner case thing. But the more important question is, and the proof has to be probabilistic, actually. Yeah. You cannot, there's no written proof. This is not math. You can't do theorems around this. You literally have to come up with a model that says, and this model cannot be you drive 100, I drove 1 billion miles because I update the software. So I found a whole bunch of issues with my software. I drove 100 million miles. Then I go, oh, I need to update the software. Are you going to drive another 100 million miles? And so every new update, which you need to put out there because your software has issues, are you going to do that? No, you're not. So you're going to obviously use some kind of simulation in the cloud. But you still, even that can be prohibitive, as it turns out. How many hours of simulation can you do with how much compute there is in the world? So now how do you decompose this problem so you can actually say, no matter what, this is going to be safe? And that to me, I think, is an area which doesn't get maybe as much attention. And I think from a research point of view, it's absolutely where the cutting edge is today.
Yeah, I 100% agree with Ashu on this one. I think this is what we call at Lyft the readiness problem, right? And I think to really solve this, it's not really just one company that can do this. I think we need to come together as an industry and maybe come up with like a model for how to demonstrate this, prove it to society and to regulators that we can be safe. And we, at Lyft, we believe that we can actually start doing this at maybe very small scale. It's easier to prove this readiness on very specific routes. And to illustrate this, I think the beauty of being at Lyft is that when you request a lift, well, we know where you are, we know where you're going, we know the weather, we know the route, we know the traffic, we know everything about the route. And we can then decide, based on this specific route, whether our tech is ready to serve it safely, right? And that's why I think we will be deploying AVs at very, very small scale first on Lyft, but alongside humans for a very long time. And eventually, the proportion will grow.
Very cool. Maybe just as a final question to wrap up here is asking us to be kind of market prognosticators, predictors here. Let's talk about kind of the broader autonomous vehicle space. Now, again, when you think about the broader category, AVs being developed in a variety of different, what I'll call like vehicle modes, there's cars, but also work being done on planes, drones, boats, robots, right, et cetera. Transportation is one macro industry, but then also we see it in delivery, warehousing, even agriculture, et cetera. And so I'm kind of curious, as you guys are experts in the field, which application do you think will kind of see broad adoption or broad application first? Who I won't point, but anyone want to start off?
I can talk to sort of the within the context of AVs. Just saying, so there's like companies maybe are looking at, we can do delivery to your doorstep, for example, versus transporting people, right? So just within that comparison, and I think that's a bit of a false choice there, because I do not believe that the delivering a pizza to your house is no harder, is no easier a problem than delivering a person. If you think about it carefully, Because yes, your pizza can jostle around and it can have an unpleasant experience. But if you have cars, and this is happening in real life, right? We're seeing that. If an autonomous vehicle behaves unnaturally, and it is in this driving alongside other human drivers, you're now going to cause the human drivers to react poorly to you. When we drive, we make so many assumptions about what the other person is going to do. And if this entity shows up that is very different and is just brake tapping, for example, it's because this is a common problem in especially in the early days of anybody building an autonomous stack. Your stack tends to have this reactive problem where it's overly reacting to things and sort of slowing down, which is not how humans drive usually. Well, maybe teenagers and very early learners, and that's why they have that sign, right? Learners. So what if you hit an autonomous delivery vehicle because it's driving so carelessly, so to speak? And so to me, I don't know that in that world of delivery versus delivering people versus pizzas, I think that's the same problem. So I suspect that world is not. I think if one is solved, the other will be solved. I think the warehouse stuff is probably going to go sooner because you can do lots of interesting things to help. You can really put rails of some kind, virtual rails. You can put markers in the warehouse. So it's a controlled environment, so you can do a lot more autonomy there.
Yeah. So
I can just maybe comment on the food delivery. I think I slightly disagree with you. I think that delivering food and goods is a lot easier because you can choose the route to be back road. You don't have to be as timely. So and as you said, you can also have an experience that's not as pleasant as elegant. So you can again brake tap, or you can have you can shake the food around or the packages around. They don't care as much. You don't have to be as elegant. So the problem is a lot simpler in my view.
So that's where we probably see some of this, happen first in real life. I think the other application we'll see of self-driving first will be in pretty constrained environments. So like you're talking about maybe retirement communities, type environment where you can go pretty slowly and the diversity of situation you encounter is lower. And as I said earlier, I think the deploying at small scale on a very specific route, that complements, the ecosystem of drivers is also what we'll see first, in my view.
Yeah, so I wanted to echo a lot of what Luke has been saying. So, the thing that's going to facilitate all of this is knowing the environment and having a controlled environment. And for a pretty long future, we're going to have hybrid systems where we're going to have in certain controlled environments and scenarios and routes at times, et cetera, autonomous vehicles will be deployable, but it's going to be a hybrid network. That's why companies like Lyft and Uber and so on are actually well poised to use this technology. But there is a lot of other spaces to think about, really. I mean, and Matt, I think you hinted at this. So there is flight, right? So autonomous. This is actually an area that Uber has been also investing in, which is there's a program called Uber Elevate, which is about aerial ride sharing. So think of commutes from say here to San Francisco in a vehicle with multiple electric propellers that is much safer and much less noisy than a helicopter would be. So that's the sort of environment that we're trying to imagine for the future, and not doing it all on our own, but building a consortium of other companies that will actually build to certain specifications, aerial ride-sharing vehicles. There is things like scooters, right? And the sort of electric scooter world could benefit from using some autonomy and perception techniques, and you can think about that. And there is freight. So freight is long haul truck driving. Runs the world in a lot of ways of logistics, right? Most of your stuff arrives in a truck somehow at some point. And the environment, although it's actually rather scary to think of an autonomous 18-wheeler or whatever, that environment is somewhat more controlled because it tends to be mostly highway driving, which is, I think my colleagues would agree, generally easier than navigating San Francisco or something like that. So that's another place where I think there is a lot of potential, and the industry is also aware of this.
Very good. All right, well, I know we're almost at the top of time. Maybe just the last round robin, kind of the most important thing you want to leave with our audience before we say goodbye from this session.
I can just say one thing, which is that this future of self-driving vehicles deployed alongside humans is already happening today. Lyft is not only building a self-driving stack, but also partnering with others to put their vehicles on the Lyft network. And so today, in Vegas, we have a partner called Aptiv that has deployed their tech. And if you go to Vegas, you have, I think 1 in 10 chance of getting a self-driving car from Lyft that's powered by Aptiv. 50,000 rides and counting. So this is happening.
Yeah, I want to kind of echo what Kyle said actually at the end of his talk. This is the moon landing of a generation, no doubt about it. And it is in many ways, no offense to all those amazing people who did the moon landing, which we just celebrated the anniversary of recently. This is going to be far more transformative. I mean, this is going to fundamentally change how millions of people live. It's going to really be very beneficial to society in terms of utilization rate. A typical car in the US is used about 4% of the time. 96% of the time it's parked, which means it's occupying space, which, by the way, is a parking spot, which could be freed up. And kind of Uber and Lyft, to their credit, have shown the way forward. More and more people are now, especially in dense urban areas in the US, are not buying cars anymore. The rate of car ownership is dropping, which, by the way, doesn't mean that the auto industry has to anything to worry about. It's just that more miles are being driven almost, or the same number of miles are being driven, maybe even more because it's the ease of availability. But what's going to happen is going to be with far fewer vehicles. And that's what's great, right? The number that always surprises me even today is the number of Ubers and Lyft serving San Francisco. And of course, they're not serving everybody in SF today in the 7x7. It's about 7,000 or 8,000 total. That's it at any given time. That's pretty amazing, that utilization rate, which is around 50%, I believe. That kind of transformation is literally going to change our city. So I'm pretty excited for that. And by the way, I also feel like a lot of people don't appreciate how quickly this is coming. It's going to happen soon.
Yeah. So the thoughts I want to leave you with are, again, echoing the fact that I used to think AI in transportation wasn't all that interesting, and now I'm completely passionate about it. And one of the reasons is, if you think about the fundamental things that we're changing, it's giving people back time, okay? We all live finite amounts of time. If you can give people back some of that time, that is hugely valuable. It's like giving them extra life. You're giving people more safety. Again, it's giving them, it's preventing those more than 1 million deaths a year that can be prevented. It's, I hope, connecting people more, right? We go places, we can teleconference, I do that all the time, but, we go places to do things, to be with other people, connecting them better. And I also hope that we can actually make the world more efficient in a sustainable way. So I'm an optimizer. I love optimizing things. And one of the potentials, and we're not there yet, but one of the potentials of AI in transportation is really to algorithmically squeeze out all of the inefficiencies that we have now, whether it's in, the carbon footprint of transporting people, or it's in the inefficiency of time that's being wasted and so on. So all those things make me super passionate about, this is the right place for AI. And I do agree, there are people now who still don't believe that the moon landing happened. Though that's evidence of the fact that the moon landing was great, but, didn't transform everybody's lives. But, once autonomous vehicles are all over the roads, nobody's going to, I'm sure there'll be somebody who will not believe in them, but, it'll be more difficult to deny that they've changed the way cities and human lives work. So.
Very great. Want to thank our illustrious panel. Thank you so much for your time. I hope you enjoyed the conversation.